Our next speaker is Minusha Indunil from Rajarata University in Sri Lanka, and he's going to be talking to us about Graceful labeling of triangular type grid graphs. So over to you, Minusha.
Hi, everybody. Good morning. I'm Minusha Indunil from Rajarata University of Sri Lanka. And today I'm here to present graph theory about my research on graceful labeling. For the easiness, I divided the whole content into 4 main topics. First, history of graph theory and research areas, then graceful graph labeling, and last but not least, a bit from my research. So I hope it is better to snip out a little bit of history of graph theory. Although there is no mention about graph since from 1836. The graph theoretical ideas can be traced back to 1735, when Leonard Euler's work on Königsberg fish problem. He wanted to find whether there is a continuous walk that crosses each of the 7 ridges of Königsberg that exactly once and come back to the same position where it started. So the solution to this problem leads to the Eulerian graph. And that means in order to accomplish the above said conditions on that 7 ridges of Königsberg, this graph has to be an Eulerian graph. So what's an Euler circuit? It's a closed straight. And in 1736, the first paper of graph theory in history was published by Leonard Euler about this problem, and he is considered as the father of graph theory. Initially, the graph theory was used to solve recreational math problems, but nowadays the graph theory has wide range of views, and it is it's significant branch of interdisciplinary research between mathematics and other sciences. So I will talk about topics for research. Actually, this is important for newcomers for this research graph theory field. There are numerous topics for research in graph theory. Among them, graph reconstruction, graph labeling, graph coloring, Ramsey theorem, shortest path, and many more. Next, under topic 3, I will discuss about graph labeling. Graph labeling is just assignment of integers to edges or vertices or both under certain conditions. And graph labeling is used almost everywhere today, especially in coding theory, X-ray crystallography, radar, astronomy, and etc. And there are different graph labeling methods too. Among them, prime labeling, graceful labeling, and harmonious labeling bit popular. Here, I attach the definition of graceful labeling. However, I would like to describe this definition in a simpler manner in my words and using some simple examples. Let me consider that total number of edges of that graph equals to Q. Then the graceful labeling is just labeling the vertices using distinct integers from 0 to Q, including 0 and Q, such that all the edges get labels from 1 to Q, and note that the label of the edges can be calculated by using the absolute difference between the labels of adjacent vertices. Let's move to the examples. Here I give example of P4, and since as you can see there are 3 edges, we have labels from 0 to 3 for the vertices. Here I have put 0 to the second vertex from the left, and I put 3 to the leftmost vertex. Then I have label 3 for the edge, and we have left 2 other vertices for the rest of the wedges. So now I have label and 1 and 2. So here I put to the label 2 to the next adjacent vertices 0, and then I need to get the label 1. So for the rightmost edge, I can use 3 and 1, but since I have used label 3 here, I cannot use it here again. So I use label 1 there. So you can see the next 2 examples too, and you can try your own. Next, I give the definition of Graceful labeling. Let me describe this concept in my own words. In normal Graceful labeling, we label the vertices from 1 to q, but here the difference is we can start the labeling from any integer k to q plus k minus 1 under the same conditions in normal Graceful labeling. And when k equals 1, we get the normal Graceful label. In the next few slides, I will be discussing I would like to share with you about my final year research work. Here, the triangular type grid graph and its formula for K-graceful labeling is shown. In the next slide, I have attached some examples too. And the formula for K-graceful labeling is given on bottom of the slide. Here, the first example is for k equals 1. That means for general 1 graceful labeling for the 4x4 triangular type grid graph. And I would like to illustrate this example using another slide. Let me divide this screen. Here, I just sketched the. I hope you can see the screen. Is it possible?
Yeah, we can see it.
Yeah, I just sketch up the vertices. I don't complete the whole graph here. Focus. I complete the first column. Here, this vertex is u11. There you get I is equals to 1 and j equals to 1. So here I is equals to 1. So the whole term vanishes, and here j is equals to 1. So the whole term vanishes. Then 0 plus 0, the labeling of this vertex is 0. Then let's consider this vertex. It's u2, 1. So I equals to 2. Here, for the even category, we have to go to the even category. So I equals to 2 and j equals to 1. Okay. Then, since this is a 4x4 matrix, n equals m equals 4. So here 3n minus 2 equals 10. Then here m is, since m is equal to 4, 2 times 4 is 8, minus 2 over 2 is 3. So 2m minus I over 2 equals to 3. So since k, here we consider the general graceful labeling, k is equals 1 and j is also equals to 1. So the whole term vanishes. Then 3 into 10 gives the labeling of 30 here. Likewise, you can get the total, you can get the complete label like using those formulas as I described here. And this labeling starts from 1 and goes up to 3. And the next example, I label the graph for k equals 3. That means 3 graceful labeling of the 4x4 triangular type grid graph. So this labeling starts from this age, from 3, and goes up until 32. And in the next slides, I discussed about k-graceful labeling of L copies of triangular type grid graphs, and each which are linked by one common point. And the labeling is, and the notation of the graph just change, because the formula for the labeling is the formula for the labeling is given in the upcoming slides. Here, the labeling method is divided into two parts depending on the parity of M and N. In each labeling method, formula for the first grid is given separately. So here the labeling is given for the M even case, and here you can see the labeling for the first grid. That means this one, and here the labeling for the M odd case. And here I have given some examples for that. So the first example is for 3 copies of triangular type grid graph, and it's given for the 5 graceful labeling. And this is, since this is 3 by 4 matrix, this is for M odd. So you have to use this labeling formulas in order to get that labeling. And in the next example, for 4 copies of triangular type grid graphs, and it's given, the labeling is given for general graceful labeling, since this labeling starts from 1, goes up to 120. Here, I present the graph of disconnected L copies of triangular type grid graphs, and the labeling method is given in the next slide. Here also, labeling method is divided depend on the parity of M, and labeling of the first graph is given separately. Here you can see the labeling for M odd case, and here I have attached some example. And first example is given for k equals 1, and for 2 copies of disconnected triangular type grid graph, and the next is for 3 copies of disconnected grid graphs, and it's 3 graceful labeling. So thank you for listening to me, and if you have any questions, it's time for questions. Thank you.
Okay, can we show our thanks for Minusha with a quick round of applause? And if there are any questions, put your hand up or throw it in the chat. Wait in case anyone's typing one out. In the meantime, I had one question. So is there a reason why you wanted to look at these triangular grid graphs? Has someone solved the problem for regular grids? And so
yes, regular grids, the problem has already been solved. And okay. I hope, so I look for some kind of new type graph. So I designed this.
Yep. Okay. I might have missed it, but if so, it would be good to reference that work somewhere in the slides, because that would help motivate why we would be interested in these. Jody's got a question in the chat which says, are there any other types of grids that you could look at and possibly use the same techniques?
Actually, today, this is my ongoing research. I'm trying to, here I use every time L copies, this is copies of grid graphs, but I'm now trying the different sizes of grid graphs of this. That means 1 point of L copies, not this is all copies, it is different sizes of copies, triangular grid graph, and the labeling method will be different. That's what I have done. Yeah.
One that comes to mind for me is you don't have the horizontal edges anymore. You've kind of replaced them with your diagonal ones. Perhaps you could look at adding those horizontal ones as well.
Mhm.
Okay, any other questions in the chat? Not in the chat. I don't see any hands up. So if not, can we once again thank Minusha for his talk?